Good morning to all of you. Okay, so we'll resume with our sessions, revision sessions. I hope these sessions are helpful to all of you. So let's start. All right. तो पहले हम रिवाइज करेंगे जो हमने लास्ट क्लास में किया था, फिर हम आज के टॉपिक्स पढ़ेंगे. तो हमने लास्ट क्लास में क्या किया था देख लेते हैं. इंटीरियर ऑफ द अर्थ हमने कर लिया था, वोल्केनोस किया था, राइट? हाँ, तो सॉरी, ओके, वोल्केनोस रिवाइज करते हैं. ऑलराइट, कहाँ थे वोल्केनोस? Yes. So हमने कल volcanoes पढ़ा था. So what is basically volcano? Volcano is nothing but a cone-shaped mountain है, which is made up of what? वही cone जो volcano के materials आ रहे हैं, dust, volcanic rocks, gases, इन सब से बना हुआ है volcano. And इसका center part is connected to magma chamber. जिससे क्या हो रहा है? From where lava rises. This is a simple definition of volcano, right? Okay. And how basically how magma is generated due to differential, or you can say radioactive elements, nuclear reaction is taking place. This releases huge amount of heat, so rock is melted, and that melted rock is known as molten magma. And due to density differentiation, that magma rises to the surface of the earth. All right, now types of lava we studied: andesitic and basaltic. Andesitic have high silica, basaltic have low silica. Andesitic is acidic because of high silica, basaltic is basic. Andesitic are viscous, that means they have low fluidity. Basaltic has low viscous, so they are more fluid. And andesitic are light color, these are black color. This we studied. Then we studied about the volcanic landforms. So volcanic landforms we studied internal and external landforms. Internal ones are known as intrusive and plutonic. External ones are known as extrusive landforms. ये यूपीएससी ने लास्ट ईयर पूछा था. Primary rocks and what are types of primary rocks. So in that types of primary rocks you had to write these only: intrusive and extrusive landforms. All right, so different kind of landforms. Internal wise, batholith, it is what nothing but irregular shaped solidified magma found beneath the surface of the earth. Secondly, vertical walls, they are known as dikes. Horizontal shape are known as sheet. If thickness is thin, then it is sheet. If it is thick, then it is known as sill. Saucer shape landforms are known as lapolith. Dome shape are known as lacolith. And if they are present on the anticline and syncline regions of folded mountains, so they are known as phacolith. That is it. This is basic thing you need to remember. Then we have extrusive landforms. Extrusive landforms we divided on the types of lava. If it is acidic lava, it would be viscous. So kind of lava that would be formed, volcano that would be formed is composite. So we have high height volcanoes. So they are also known as composite and stratified lavas. Examples 2-3 you can remember: Mount Stromboli and Mount Vesuvius. So they have andesitic lava, acidic, viscous, and they are more explosive. Why explosive? Because since they have low fluidity, if lava is rising and they cool and solidify in the vent itself, so next batch of lava would have to first destroy this, and only then it would be able to come out. So that's why they are explosive. Then second type of volcano, we have shield type. In this, what we are having, basic lava. So basic lava, they have high fluidity. So kind of volcano that is formed is low height one. They have wide base and low height, so they're not steep. So best example is Hawaiian type of volcanoes. I hope you know where is Hawaiian. Hawaiian is present in Pacific Ocean, and these are less explosive. Next type of fissure type of landforms. It is very silent type of landform. Volcanic eruption. Lava is rising. It just rises to the surface of the earth and starts spreading without causing any explosive activity. So it leads to formation of plateau and plains. So various plateaus that have been formed, you need to remember. In Russia region, we have Siberian trap, right? Then Canadian Shield, Snake Basin, or you also call it as Columbian Plateau. Right? Then we have Colorado Plateau भी है यहाँ पे, Colorado Columbian. Then Icelandic Shield, Deccan Trap. In case of India, how it was formed Deccan Trap by a reunion hotspot. Right? Just keep this in mind. Then crater caldera cinder, we saw basic difference. Crater is nothing but it is a ball shaped depression shape in which center is connected with the vent. Vent is connecting magma chamber. Inverted cone shape, vent is present, crater lakes are formed. So now best example is Lake Toba in Indonesia. It is largest crater lake of India. Sorry, world. In case of India, we do find crater lakes. It is known as Lunar Lake, but that crater, that depression is formed not by volcanic eruption, rather by meteor. Keep this in mind. Then we have cinder cones. It is also inverted cone only, but there is presence of rock fragments in the cone itself and also in the vent. So this is cinder cones. And large size crater or cinder cones are known as caldera. But how it is formed caldera? Usually in magma chamber contains all the lava. This gets emptied. So when this gets emptied, so now what is happening? We have empty structure, and over there above we have various rocks present. So what will happen? There will be collapse of wall of this magma chamber. So ultimately, what would be left if this is whole structure? So what would be left? Only at the center, some parts would be left. Rest part would be collapsed, and they will fall down in the below part. So this is how it will look. So this is full. If you look at from the bird eye view, so it will look like this: land surrounded by depression. So it will look like this, surrounded by cave. So when water fills up, it forms caldera lake, or we also call it as crater lakes. All right. Then we study about hotspot volcanisms. What are hotspot volcanism? In this also volcanic activity is taking place, but they are fixed across the surface of the earth. So as the plate moves over them, what would happen from these spots, fixed spots, lava will come out as new plates move over it. So lava will come out and they will make cracks on the plates and they will erupt on the plates. And when they erupt on the plates, they will form same kind of landforms, mountains, plains, plateaus, and all. And as plates move ahead, what would happen? That older mountain that has been formed, it would be cut off from the vent because that vent would be connecting the new mountains. So it leads to formation of volcanic chain. Keep this in mind. Also, it may form the plateau also, like Indian Peninsula when it moved over the reunion hotspot, electric formation of Deccan traps. Right? And what are the sources of molten magma? Core mantle boundary, asthenosphere. Right? And in case of hotspot volcanism, from where magma is coming, it is coming from core mantle boundary. Otherwise, in normal activity, volcanic activity, magma may come from asthenosphere also. Right. Then we studied about another kind of volcanic landforms जो इंडिया में दिखते हैं, because इंडिया में volcanic eruption नहीं हो रही because of continent convergence. So the thickness of crust is more, so lava is not able to come to the surface of the earth. So what we find, hot water and geysers, where Puga Valley in Ladakh. Now recently government of India has started geothermal project in Puga Valley. Also we have Manikaran region in Himachal Pradesh. Right. Then we have Tattapani region in Chhattisgarh. Right. So these are the areas. So what are hot water springs and geysers? It is nothing but if there's a water body, and suppose below we have hot rocks. So these water body will come in contact with the hot rocks. So their temperature will increase. So ultimately this whole water body's temperature will increase. These are known as hot water springs. And where hot rocks would be present, wherever there are cracks are present, through which from magma chamber lava is able to rise, first of all. Secondly, if this water gets heated up beyond 100 degrees Celsius, and also this presence of water, what will happen? Water will rise at fast pace and it will create fountains. That is known as geysers. Just remember this. In geysers, we find a bit colorful. It is due to silicate deposits. Hot water springs are colorful because of presence of cyanobacteria. Okay. Then in India, we do find volcanic activity, we have two islands, Barren Island and Narcondam Islands. Barren Islands are what? They are found to be active. They were recently erupted in 2017. Narcondam Island is the extinct one. Keep this in mind. Then what are gases released? Hydrochloric acid, ammonium chloride, sulfur dioxide, carbon dioxide, hydrogen, nitrogen, hydrogen sulfide, carbon monoxide, fumarole, sulfur taras. This you have to remember. Mug it up. All right. In India, barren only active volcano, Narcondam extinct volcano, Andaman Nicobar Islands. Right. Actives are those in which eruption of volcano is taking place frequently. Dormant, not frequent eruptions, extinct. They have not taken in the historic times. And order of volcanoes in terms of density of eruption: Hawaiian eruption, Vedic Common, Strombolian, Vulcanian, Plinian, Pelian. Just remember this order. All right. So this is we studied about the volcano. Now our next topic was geomorphology, where we started studying about the distribution of ocean and continents. So various theories have been given to explain the distribution of oceans and continents. First theory is continental drift theory. Then convection current theory by Arthur Holmes, seafloor splitting by Harry Hess, plate tectonic theory by Morgan, Parker, all these people. Right? Okay. So now, first theory. What you just have to remember the basics. What was the continental drift theory? It just simply said 200 million years ago, there was presence of large continent mass known as Pangaea, surrounded by large water body Panthalassa. This got broken up into two, Laurasia, Gondwana land. Further, this got broken up, Laurasia and Gondwana land, and this led to the present distribution of continents. I hope you know present continents. Europe, Asia, North America, South America, Africa, Australia. Then over here we have Antarctica. So these are the present continents and also oceans. You know, Pacific Ocean, Atlantic Ocean, Arctic Ocean, Southern Ocean, Indian Ocean. I hope you know all these oceans. All right. So according to Alfred Wegener, it is the continents that are moving. And what are forces responsible? Pole fling force. Pole fling force is due to rotation of the Earth, and tidal force due to gravitational pull of Earth and Moon. Okay, what all evidences it gave? It said geographically, if we look at two places, Africa and South America. So this eastern part of Africa, it fits with the western part of Africa. So it says that in the past they were joined together and now they got separated. So this is one evidence it gave. Then it gives geological, that means rocks of the same age. That rocks across the oceans are same. Earlier they were joined, so that means both the areas having same rocks. It is possible only because they were joined together. So it said in the Africa we find, in the Ghana coast we find gold, right? Placer deposits. But in case of but source of gold is missing. So where is source present? In the Brazil region. So placer deposits region has been given. Also rocks. If you find the rocks in the western coast of Africa and eastern coast of South America, they are found same. Also it gives rocks of these also. You can write in the North America we have Appalachian Mountains. Also in these western part of Europe we have Scandinavian mountains. They are also similar. All right. Then it gave the example of the fossils and tilites. It said in the Gondwana land, which all countries continents were there: South America, Africa, Madagascar, Peninsular India, Australia. Then we have Antarctica. So according to it, first of all, in all these regions there were glacier deposits, which are known as tilites. So how glacier deposits are present in all 6 regions? Because they were first once joined together, there was glaciation process, and during which glaciers deposited sedimentary deposits, which are known as tilites. This was another reason. Then fossils, it has found, it gave the example of Lemuria, right? Then also it gave the example of Mesosaurus. Mesosaurus is found where? In South America and Africa, sorry. So these were the examples given, right? But why this theory was not successful? First, forces it gave. It is inadequate to move. Secondly, why it took the 200 million years ago as the cutoff line. And then jigsaw fit, according to today's computer, or you can say scientific techniques, that South America and Africa coast, they don't fit a jigsaw fit at the present coastline, that coastline we are seeing right now. Rather, they fit if you go at the depth of 1000 Fathom line. At that position, they fit, jigsaw fit each other. So these are the examples. All right. I told you about Falkland Island also, right? Yes, Earth we studied about, ocean 71%, continents 29% combination, and that's why it is Earth is known as blue planet. Then initially, this jigsaw fit of Europe and Africa was given by the Abraham Ortelius, then Antonio Pellegrini. Just basic name. Even if you don't remember, no worries, because UPSC is not asking question from here. All right. Appalachian and Caledonian Scandinavian mountains of Europe, they match, rocks of same age, right? All right. This is we studied about, right? So these are the example of fossils, right? So Mesosaurus are found across South America and Africa, right? Then Glossopteris. This is a plant which is found across all the 6, right? Lystrosaurus is found across Africa, Madagascar, India, and Antarctica. Then Cynogathus, South America and Africa. See, even if you are not able to remember all the examples, just remember 2 examples which are given in the NCERT. These 2. Lemurs are found across India, Madagascar, and Africa. These region, these 3, and these 2, South America and Africa, you have Mesosaurus. These 2 examples you have to remember. Rest of the examples, if you can remember. If you don't, even then it's fine. Delights across all 6, Glossopteris all 6. All right. So this is all about yesterday's session. Okay. So now let's continue with our today's session. Now I hope after revising yesterday's session, all the facts would be in your mind. Okay. So let's continue. So basically, in case of continental drift theory, there was biggest lacuna was that it was not able to tell what are the forces which are responsible for moving the large size continents. So new theory came, convection current theory. So new theory came, convection currents. So according to Arthur Holmes, what it said, that inside the earth there's a genesis of the magma. So if magma is created, so this magma will rise, and as they will rise, there's a presence of crust. So what will happen? Crust will block the movement of the magma. So magma will diverge. It will create limbs, arms of the magma, and as it will move, what will happen? It will drag the crust also along with it. So ultimately, this will lead to formation of cracks. So ultimately, in this region, what is happening? Since it drags along with it, crust will move. As crust is moving, so we can say part of the crust is moving, continents are moving, and in between it will create the cracks. And after some time, because at this point their temperature is high, but as they will move up towards the surface, the temperature will cool down, because we know temperature decreases from surface to core. So as we move from core to the surface, temperature will decrease. So ultimately, when they reach the top of the surface, they will cool down, and ultimately they will subside down. And as they will subside, they will drag along with themselves part of the crust also. So where the point where magma is rising, over there leads to divergence of crust, and point where magma is falling down, they leads to convergence. So it looks like this. Magma is rising, it is dragging with itself. So it creates divergence, and here magma is falling down, so it drags the plate, or you can say crust, along with it. So here it creates the convergence. So trenches are formed. So this is convection current theory. So this concept was basically used by seafloor spreading, and today's time this is most acceptable theory for the movement of plates. Okay, so seafloor spreading. So what happened after World War II? There were a lot of discoveries. So Arthur Holmes said there is operation of convection currents in the mantle portion. And how convection currents are formed? Basically, molten magma is formed. So release of heat, radioactive elements, and residual heat, they are responsible. All right. So after World War II, what happened? We did the mapping of the ocean floor. So everyone was shocked. They had thought that ocean floor was plain. They had no landform features. But during World War II, we found out that there presence of what landform features, like mountains, are like mountains we have on the land, we find it on the ocean floor also. So mountains, plateaus, volcanic activity, earthquake, all these were formed. So ultimately, this led to the exploration of the ocean floor. So what all was found while exploring the ocean floor? So this was, so we found out that ocean floor looks like this. So ocean floor has various features: continental shelf and continental slope, rise. Then it has plain, which we call it as abyssal plain. Then trenches are present, like valley we found on the land surface. Valley found in the ocean surface are known as trenches. Then it has mid-oceanic ridges. So these were the landforms that were formed. And in case of land, average height is around 800 meters. In case of water, average depth is around 3,700 meters. Just keep this thing in mind. Right? So what we have, continental margins, we'll see in the oceanography topic also. So these are transition zone between continental shores, there are beach area, and deep sea basins. So continental margins consist of what all? Shelf, slope, continental rise, and deep ocean trenches. ये ध्यान रखना. Continental margins include all this, even trenches also. Then abyssal plains, these are between continental margins and mid-oceanic ridges. These are the areas between. So it looks like this. This is how oceanic surface looks. Continental shore, slope, shelf. Then we have slope. Then we have rise. Then we have trenches. And between trenches and mid-oceanic ridges, we have abyssal plain. And where mid-oceanic ridges are formed, where convection current is rising. It causes splitting of the oceanic crust, and through that, magma comes out, erupts, and forms the mountains, which are known as mid-oceanic ridges on the ocean crust. And these are what? These are the longest mountain chain on the surface of the earth, right? And the zone of intense volcanic activity. Just keep this thing in mind. All right. Distribution of earthquake and volcanoes. We'll just look it in a while. All right. So ultimately, there were few discoveries. What all discoveries after World War II? That first of all, at the ocean surface, we have various landforms. Volcanic eruption is taking place along the mid-oceanic ridges, first of all. Then, if mid-oceanic ridges are formed, so what we found? Rocks on the equidistance. Suppose at 5 kilometer distance from this mid-oceanic ridge and 5 kilometer distance from here. So rocks which are found, they have similar properties. Similar properties in what? Period of formation where when they were formed, chemical wise, magnetic properties, they were having similar properties. So this amazed scientists. Why is it possible? How is it possible like this? So even they had these magnetic properties same polarity wise, right? And also what was found, as we moved from mid-oceanic ridges away from the mid-oceanic ridges, what we found, age of the rocks increases. So what we find at near the mid-oceanic ridges, youngest rocks are found. But as we move away from it, age of rocks increases. So oldest rocks are found away from the mid-oceanic ridges. This was another kind of discovery. Then what we found, oceanic crust. We studied the age of the oceanic crust across all the oceans, and we found out that nowhere age of the oceanic crust is more than 200 million years ago, first of all, and age of the all the oceanic crust is lesser than continental rocks. So this was another discovery. Then sediments, because of erosion activity, sediments are formed on the surface. So on the ocean floor, we found that sediments on the ocean floor are very thin, not thick like land. All right. Then we found out trenches that valleys are formed. They are deep. Over there, we have deep-seated earthquake. See, depending on the depth of the foci, we divided earthquakes. Suppose this is interior of the earth. So foci focus, what is focus? It is a point where earthquake is released, energy is released. So we, if the depth of the foci from the surface of the earth is less, they are known as shallow foci earthquake. And if depth is more, they are known as deep foci earthquake. Right? Keep this in mind. So what we found along the mid-oceanic ridges, we found quake foci have shallow depths. That means depth of the foci was shallow. And along the deep trenches, we found it deep-seated earthquakes. So keep this thing in mind. All right. So ultimately, these were the discoveries. Now scientists wanted to explore the reasons. What were the reasons behind it? So to explain this, new theory came by Harry Hess, seafloor spreading. So what it said, seafloor spreading? It simply said magma is rising. So what it does, it drags the oceanic crust along with it. So as it drags with it, what happens? Splitting of oceanic crust took place, it led to the formation of mid-oceanic ridges. Mid-oceanic ridges were formed. So ultimately now lava will come again. It will lead to formation of new set of rocks. Now again, new lava will come. It will push the already formed rocks. So new rocks, older rocks would be pushed ahead. Again, lava will come. New rock would be formed. Older rocks would be pushed. So likewise on the left side also. So we found out that because of this reason, we have rocks at equidistance from mid-oceanic ridges have same properties. And age of the rocks is increasing as we move from mid-oceanic ridges, right, away from the mid-oceanic ridges. Why? Because older rocks are pushed away from the mid-oceanic ridges by the new volcanic eruption. Then now this magma is moving. After some time, it will subside down. So at this, as it subsides down, it will along with, it will drag the part of the lithosphere along with it. So at that region, what would happen? Trenches would be formed. So at the surface, if there are any sediments are present on the surface or any rocks, they would also move along with it towards the trench. So what is happening? Older rocks get destroyed in the trenches because as they move inside the earth of interior of the earth, what would happen? Temperature would increase and they will melt, and these rocks would get destroyed. So that's why as we move away from the ocean, although older rocks are formed, but rocks beyond the age of 200 million years, they are not found because they all have been destroyed at the trenches. And same is the reason why we have thin layer of sediments, because all the sediments that have accumulated, they also move towards the interior of the earth along the trenches and they get destroyed. So I hope you have got the basic idea. And it has shallow earthquake because movement of crust is taking place at the surface only. So earthquake foci is created at the near the surface only. So that's why it has shallow earthquake. Earthquake is what? Simply jerk or energy needs to be produced. So at what point energy is being produced? Along the plate only or crust only, because over here it will split and crack will be formed and earthquake will occur. So I hope all the facts which were discovered after World War II have been explained by the seafloor spreading itself. All right. So this is about seafloor spreading. So at mid-oceanic ridges, volcanic eruption takes place. So new crust is formed, new rocks are formed. But at the oceanic trenches, crust is destroyed. To explain this, it gave the concept of paleomagnetism. So what it said, if this is mid-oceanic ridges, so if we have rocks, this is a layer of rocks, same color rocks. So they have same kind of polarity. That means same kind of magnetic property. So basically, what is magnetic property? I'll give you the basics. See, See, paleomagnetism. First of all, what is paleo? Paleo means rock, and this is magnet. So basically, study of rocks magnetic property. Like this is paleomagnetism. Simple terms mein. We don't need to understand the complex definition. We are studying the rocks magnetic property in order to understand the basic features. Right. So this would be used to explain the seafloor spreading and also plate tectonic plates. So what it says. Now see. Suppose at present Earth's magnetic field looks like this: North Pole, South Pole. Now, along the mid-oceanic ridges, a new kind of rock is formed. This is rock 1, rock 2, because they are equidistant from the mid-oceanic ridges, so they would be having same property. So now, so if rock is heated above Curie temperature, एक temperature होता है, you just need to remember Curie temperature. What would happen? जो ions होते हैं, or you can say electrons inside the minerals, they will align. Minerals of rocks will align with present magnetic field. तो मैग्नेटिक फील्ड प्रेजेंट क्या है इस डायरेक्शन में. सो रॉक्स में कैसे दिखेंगे हमें, ऐसे अलाइन होंगे. Right? So this is how magnetic rock will appear. Now if this magnetic field gets reversed, suppose it's like this, so it would happen, new kind of lava will erupt, and if temperature is above Curie temperature, so minerals in the rocks, new rocks, they will align in this direction. So we call it as this as suppose normal polarity. So we call this as reverse polarity. Then again in future what happens? Magnetic field again reverses. So new set of rocks will be created. It will look like this. So if we look at the ocean floor, how it will look? If this is mid-oceanic ridges, right? Now rocks are formed. Suppose one layer of rocks are formed. Now they are pushed by the new set of rocks. So imagine older rocks are over here. They have normal polarity. Then new rocks were formed. They have reverse polarity. Then again magnetic field got reversed. We have normal polarity. And now present new rocks are being formed. They have reverse polarity. So what we found strips of the rocks. And all the rocks equidistant from the mid-oceanic ridges were having same magnetic property. Now how was this possible? So basically what it shows, how it shows the seafloor spreading. We need to understand this fact. Now see. Earlier this particular rock, where was it present? It was present over here. But in the future, we know it's through its magnetic property. Suppose this is aligned in this direction, so we can ascertain its age through radiometric methods and all, carbon dating. So we can tell when these rocks were formed, and accordingly we can tell if these rocks were formed. Suppose these rocks were formed 100 million years ago, and where they are supposed to be formed, they are supposed to be formed near the mid-oceanic ridges. Over here they need to be formed near the mid-oceanic ridges, but in present time where they are being found they are being found over the some distance from the mid-oceanic ridges. So that means they have moved away. Then again we found out age of these rocks. They were 90 million years ago. These were 70 million years ago. Then these are present to 60 million years ago. So what it shows, the rocks are being formed in various times, and they have been formed in sequence, and they have been pushed by the newer rocks. So older rocks are being pushed away from the mid-oceanic ridges. So we found it with the help of the magnetic property. So because we know in the past when magnetic field direction were changed. So we use that knowledge also to ascertain the age of the rocks. So magnetic properties or change in direction of magnetic field. This was used to ascertain or determine age of rocks. And this proved that seafloor is spreading. Alright, so this was the basic concept of seafloor spreading. I hope you've got the basic idea. So this was used as the evidence to explain the seafloor spreading. All right. Now next theory, what we have, plate tectonics. So it was given by whom? Mackenzie, Parker, and Morgan. Seafloor spreading basically proved all World War II discoveries, post World War II discoveries. Plus evidence क्या दिए थे हमने? Evidence was paleomagnetism. So this was used to explain. All right. Now next theory comes plate tectonic theory. Most important theory. See, important keyword that you need to remember is it is unifying theory. Plate tectonic theory. So let's look at its keywords. It is a unifying theory. Why it is a unifying theory? See, first of all, it unifies the concepts of continental drift theory. So it says, yes, there is a drifting of continents is taking place. It uses this concept. Then convection current theory, it uses this concept. Yes, forces responsible for drifting is convection current. Then seafloor spreading, it uses the concept of yes, there is a seafloor spreading taking place. Also, it uses the concept of paleomagnetism to prove itself. This, along with it, it gives its own concepts. What concept it gives? Plates. What it says, now it doesn't talk about any continents. It doesn't talk about crust. It talks about lithosphere. So what are plates? The lithosphere region, crust and upper part of mantle, which is floating over the asthenosphere. So that lithosphere part is broken into parts, which is known as plates. First of all, keep this thing in mind. Now it said, it gave the concept of plates. It said there is a movement of plates. Force these में, it uses the concept of convection current force, which are responsible for the movement of the plates. And then it says various features like volcanoes, volcanic activity, earthquake, mountains formation, trenches. All these are formed due to interaction of plates. This is this theory all about. I hope you have got a basic idea. It first unifies the theory, unifies the earlier theories. Then it gives its own concept about plates. Then it says plates are moving due to convection current theory. Convection current, and all the features like volcanoes, earthquake, mountains, all have been explained due to interaction of the plates. Now it says there are three types of interaction. So one is convergent type of interaction, divergent, and transform. Transform, divergent, convergent. So these are the three types of interaction which this theory talks about. First of all, you need to know. All right. So now, using these three types of interaction, it will try to explain the various landform features. Okay, before heading for it, what is plate? Also called lithospheric plate, is a massive irregularly shaped slab of solid rock. So basically, lithosphere has been broken into parts known as plates. And plates may consist of both continental and oceanic plate, or plate may consist of only oceanic plate, also oceanic crust also, or continental crust also, or may consist of both oceanic plus crust continent, sorry. And plates are moving horizontally over asthenosphere. And how they are moving? With the help of convection current. So thickness of plates may vary. Along the oceanic parts, we have thickness of plates 5 to 100 kilometer. Along the continents, we have 200 kilometer. Now we have 7 major plates, which you need to remember. 7 whole Earth is divided into 7 major plates. North American plate, which consists of both continental and oceanic part. Oceanic part is where Atlantic Ocean. Eurasian plate, it consists of continental part and oceanic part of Atlantic Ocean, and some Pacific Ocean part also. Right? And North American plate also has some part of Pacific Ocean. Just keep in mind. Then we have Pacific plate. It is completely oceanic plate. South American plate consists of continent part and oceanic part of Atlantic Ocean. African plate consists of oceanic part of Atlantic and Indian Ocean. Then Indo-Australian plate, Indian Peninsula, Australian Peninsula, and also we have Australian landmass and Indian Ocean part. Also some Pacific Ocean part. Then Antarctic Ocean, Southern Ocean part. So these are the 7 plates: North America, South America, Pacific, African, Eurasian, Indo-Australian, and Antarctica. Right? These are the 7 major plates. Then we have minor plates also. Which all are the minor plates? We have Cocos plate, Caribbean plate. Remember, Cocos plate is between North American Pacific plate. Caribbean plate between North American South America plate. Nazca plate between Pacific and South American plate. Scotia plate between Antarctica and South America. Arabian plate between Eurasian and African plate. Then we have Indian plate, part of Indo-Australian plate only, but yes, some plate is forming. It is between Africa, Eurasian, and Indo-Australian plate. Then Philippine plate, this is Philippine Island. It is between Eurasian and Pacific plate. Also, you can remember one more plate. It is part of this only Eurasian plate only, but over here we have Sunda plate. But it is part of this only Eurasian plate only. All right. So keep this thing in mind. These are the minor plates: Cocos, Nazca, Arabian, Philippine plate. In NCERT, what else is given? You have one more, Caroline and Fuji plate also. You can mark this also. Over here and over here. This is Carolina plate. This is Fuji plate, because it's mentioned in NCERT, so we have to remember. So just this diagram is enough. Major plates and minor plates. All right. And do remember their location also, because the boundaries of the plates, these boundary of the plates, they are very important, because it is these boundaries of the plates where all the phenomena are taking place. So you will observe all the phenomena along these boundaries only. So you have to remember this map. Yes, Juan de Fuca plate also. This was missed. So, all right, these are the boundaries of the plate. You can see this map also. Caroline plate, Philippine plate. All right. This is NCERT map. And also you need to remember what kind of movement is taking place. So let's have a look at that. So kind of interaction that is taking place along the margins. Continent convergent interaction. First of all, you need to just mug it up. Evidence in support of plate tectonics, paleomagnetism, young age of the ocean floor, gravitational anomalies, earthquake and volcanoes. All this shows that plates are moving and interacting. Gravitational anomalies nothing but along the trenches area. So what is happening over this region? There should be presence of mass of upper plate also, lower plate also. But what is happening in lower plate? Some part gets destroyed because it is entering in the interior of the earth. Temperature increases, it melts. So this part gets destroyed. So ultimately, there presence of less material, mass material. So actual value of gravity that we are expecting it turns out to be less because gravity is proportional to mass upon radius. So mass turns out to be less because some mass is destroyed. So along the convergent boundary of trenches, subduction takes place and there is loss of material. So we have value of G less as compared to expected values. So these are the evidences. All right. So types of interactions, convergent boundary. In case of convergent boundary, depending on the type of plate, oceanic plate, continental plate, we can have the three types of interaction: oceanic convergent, oceanic plate interaction, oceanic plate and continental plate interaction, continental plate and continental plate interaction. Right. So in case of oceanic interaction, what we are founding, there's formation of island arcs, volcanic activities present. So volcanic islands, you can say, trenches are formed, earthquake activities. So these things you need to remember. What are landforms and activities are being formed? So how activities taking place? So oceanic plate. See now question rises. See, both the plates are denser. Oceanic plate also, oceanic plate 1, oceanic plate 2. So now question rises, which plate would subduct? So how we determine it? Now see, uh, oceanic plate, there's another oceanic plate, but yes, in some part it would be having continental crust also. So if we calculate the density of the both the plates, so plate having whole part occupied by the oceanic crust, it would be having more density as compared to plate having oceanic crust and continental crust combination. So this plate oceanic crust would subduct. This would, because this would be more denser, this would be lighter. And we know if truck and car collides, truck stays over there, it's only the car which flies, as we have seen in the movies of Rohit Shetty, right? All right. So oceanic crust and so this is how interaction will take place. Now what would be happening? See, as this part subducts, this part will break off, this will melt into molten magma. Why? Because temperature increases, rocks will melt. As rocks will melt, again, through density differentiation and buoyant force, they will start rising. So as they will rise, we know thickness of oceanic crust is less, they are thin. So magma would be able to rise, and as they rise, they will create volcanic mountains. And also, this is whole plate. So along the whole plate, volcanic lava is rising. So it will lead to formation of what? Volcanic arcs. And since they are submerged in the water, this is oceanic crust submerged under the water. So as their height will rise, it will look like islands. And since they are continuous chain, they are forming island arcs. And also volcanic activity is taking place. So, and over here at the conversion point, we have trenches. And in case of these trenches, they are deepest trenches in case of oceanic crust. So, and also at this point, because this part will break off, so there will be production of jerk. So this leads to formation of earthquake. And since trenches have been gone down, sorry, oceanic plate, so that earthquake for Psyche, it is at deep seated. So what you are observing, deep seated earthquakes. So I hope you have got a basic idea. Trenches are being formed, island arcs are being formed, volcanic activities taking place in those, and deep seated earthquakes. Deepest trenches, and deepest trench of the world is Mariana Trench. All right, so let's have a look at the examples. See, oceanic convergence कहाँ कहाँ पे हो रही है वर्ल्ड में? Let's have a look at. If you look at this map, see convergent boundary. कहाँ कहाँ पे हो रही convergent boundary? अगर हम देखें, ये triangles वाली convergent boundaries है. यही एरिया है जहाँ पे कन्वर्जन बाउंड्री हो रही है वर्ल्ड में. बाकी जगह क्या है, डाइवर्जेंट या ट्रांसफॉर्म. सो अगर हम इस रीजन्स में देखें, यहाँ पे ओशियानिक ओशियानिक, बिकॉज ये पार्ट ओशियानिक का है, ये ओशियानिक पार्ट, ये ओशियानिक पार्ट, ओशियानिक 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 पार्ट, ओशियानिक ओशियानिक. यहाँ पे क्या है, कॉन्टिनेंट कॉन्टिनेंट. सो इन दीज रीजन्स व्हाट यू आर फाइंडिंग, oceanic oceanic convergence. So over here we find the formation of the islands. So over here we have Philippine Island, Indonesian Island, Japanese Island, Kuril Island, Aleutian Island, then these Pacific Islands, New Zealand. So these are the landforms all formed by a convergent boundary. And UPSC had asked question in previous year also ki how Indonesian and Philippine archipelagos have been formed. Archipelagos are nothing, chain of volcanoes. So Philippine Island, now you need to remember the plates also, because UPSC may ask that particular island has been formed due to interaction of which all plates. So Philippine Islands have been formed by Philippine plate, Sunda plate. Sunda plate is part of Eurasian plate only. So instead of Sunda, you can write Eurasian also, but sometimes Sunda is also written. Then Japan Island, it is formed due to Eurasian Island, Philippine Island, Eurasian, Philippine plate, and Pacific plate. So through these interaction, so Japan has many islands. So lower island has been formed through subduction of Eurasian and Philippine plate, but rest of the islands have been formed by Eurasian and Pacific plate. Then we have Kuril Island, then we have Aleutian Islands. So in case of Kuril, Eurasian and Pacific plate. In case of Aleutian Islands, we have North American and Pacific plate. So through this, and trenches that have been formed in Japan, it is known as Ryukyu Trench. In case of Philippines, it is known as Mariana Trench. Likewise, Indonesian islands, they have been formed by Indo-Australian plate and Sunda plate. And trench that has been formed, it is known as Java Trench. We know along the Java Trench only tsunamis were created in 2004. Right? Okay. Then another ocean convergence example is in the North America, South America part, we have Panama Isthmus. We know North America, South America, it is connected by landmass which is known as Panama landmass and Panama Isthmus. What is isthmus? Isthmus is nothing but a land body which is connecting two water bodies. So it is Panama Isthmus. So over here we have Pacific plate, Caribbean plate, and South American plate. These three plates interaction leads to formation of Panama Isthmus. Also in Caribbean islands, what we are observing, Caribbean islands are divided into two groups: Greater Antilles, Lesser Antilles. All right. So Greater Antilles in the past, how they were formed? North American plate. Over here we have Caribbean plate. Caribbean is a minor plate. So subduction of this North American plate under the Caribbean plate, and this led to the formation of Greater Antilles Island, Cuba and all these, Cuba, Haiti, Jamaica, Dominican Republic, Puerto Rico, Cayman Islands. So these were formed, even Bahamas. So these were formed, and trench that was formed was Puerto Rico Trench. Right. Likewise, we have another set of islands, Lesser Antilles. They have been formed by Caribbean plate, and over here we have South American plate. So through convergence of Caribbean and South American plate, it led to the formation of Lesser Antilles. So Lesser Antilles include Dominica, Saint Lucia, Grenada, Barbados, British Virgin Islands, Trinidad and Tobago. And these are the few islands where recently Vice President of India also visited. Right? We'll see the places in news of the current affair. So I hope now it is clear. Greater Antilles, Lesser Antilles, and currently Lesser Antilles are active ones here. Still, subduction is taking place between Caribbean plate and South American plate. So volcanic activity is found over here. But in case of Greater Antilles, in the past there was subduction, but now in case of conversion boundary, now here we find transform boundary. So no subduction is taking place anymore. Keep this thing in mind. So these are the examples of oceanic convergence. I hope you will remember. It leads to formation of island arcs, trenches. Deepest trenches are formed. Earthquake are deep-seated earthquakes. All right. So next type of interaction is, this is how Japan has been formed: Eurasian plate, Philippine plate, Pacific plate. So one group of islands have been formed by subduction of Philippine plate under Eurasian. Another set of islands of Japan has been formed by subduction of Pacific and Eurasian plate. All right. Then we have next set of convergence, ocean continent convergence, also known as Cordilleran convergence. Yesterday someone was talking about these Cordilleran convergence. So what are Cordillera? These are nothing but the way chains of volcanic mountains have been formed. Likewise, chain of mountains would be formed on the land continents. So these are known as Cordillera. Mountains, instead of volcanic arcs, we have continental arcs known as Cordillera. Trenches were formed in ocean-ocean convergence. Same trenches are formed, but not as deep as ocean-ocean convergence. Then mountains are formed. Earthquake activities will be taking place. Volcanic activities would be taking place. Right. Then mountains are formed, fold mountains, and also another set of mountains are formed, which are known as accretionary wedge, which is responsible for crustal shortening. So let's have a look at how it is. It will look in the same way. Just instead of oceanic plate, and over here you just write continental plate. So same way, part of oceanic plate melts, magma rises, leads to formation of volcanic mountains. I'll draw it again. Oceanic plate, continental plate. Now we know thickness of continental plate is most as compared to oceanic plate. Right. Now part of magma melts and rise. Now since thickness is more, so magma is able to rise from few spots only, not from all. So this leads to formation of parallel ranges, parallel mountains, right? Then also this part will get uplifted because magma will start hitting from below. So this will lead to upliftment of this part. So we have uplifted land, or we call it as plateau. And then rivers will also bring sediments. So these sediments will get accumulated in the trenches part, and due to compression force, as plates are moving towards each other, due to compression force, what would happen? Another set of mountains would be formed due to squeezing of sediments. These are known as accretionary wedge. And this region would be known as trenches. So trenches, accretionary wedge, uplifted land, plateau, and parallel mountains, parallel mountain ranges. These would be formed. And of course, since over here earthquake activity will take place, we have deep-seated earthquakes. Then in these mountain ranges, we would be having volcanic activity because they would be connected by vent through which magma would be rising. So we have volcanic mountains. So these are the forms. And since these are formed, mountains are formed all along the continents. So this leads to formation of continental arcs, right? Also known as Cordillera. Keep this thing in mind. Okay. So these are the basics of the ocean continent convergence. So if we look at the examples where they are found along the plates, Rockies Mountain has been formed by the same. So which all plates are involved? Pacific plate, North American plate, Juan de Fuca plate. Likewise in South America, which all plates are involved? Nazca plate and South American plate. So Andes Mountains are formed. So which trench? Famous trench known as Peru-Chile trench is formed. And also accretionary wedge that is formed is known as West Chile, because Chile country is there. So West Chile coast range. Likewise, we have, in case of Rockies also, we have coast range also known as Cascade range. Right? Okay. So do keep this fact in mind. In case of Argentina, Chile border, or along these Andes only, we have active volcano which is known as Ojos del Salada. It is highest active volcano because it is present at highest height. height over 6893 meter. Otherwise, in the whole solar system, highest volcano that we have found is Olympus Mons on Mars. All right. Then we know highest peak is Mount Everest. Then highest peak outside the Himalayas, it is Mount Aconcagua. Argentina में along the Andes only Mount Aconcagua. This is highest peak outside the Himalayas. Otherwise, Himalayas, we know we have all the peaks of height around, average is around 8868 meter. This is the height of the peak of the Everest. Then we have K2 peak, Kanchenjunga peak. We have many peaks. But outside Himalayas, we have highest peak is Mount Aconcagua, and it is extinct volcano. Keep this in mind, right? So in this region, over here also convergence is taking place, but it's between ocean continent. So this is about second set of convergence. Now we have third set of convergence is continent. So let's have a look at these convergent boundaries. Next set of convergence are continent convergence, or we also call it as Himalayan convergence. Now see, there's a one term suture zone. Suture zones are nothing but it is a point where two continents meet. Two continent plates are meeting. That is known as suture zone. Likewise, we have Eurasian plate, Indo-Australian plate. They meet at suture zone, which is known as Indus-Sangpo suture zone. Because many of you don't know about this definition, so it should be clear. What is suture zone? All right. In case of continent convergence, also we have deep foci earthquake. Now, see how continent convergence is taking place. See, continent convergence, it takes place in two phases. Phase 1, phase 2. So in case of phase 1, what is happening? Continent, ocean, continent. This is how scenario is. So initially conversion will take place between ocean continent. So it will look like this. We have continent, oceanic plate, continent plate. So again, same features would be found. Ocean continent, melt, mountains would be found. Right? Over here, trenches, deep-seated earthquake, volcanic activity. This would be found. Now, once what would happen? This whole oceanic plate moves below the continental crust, continental plate. So in future, what would happen? Continental plate, over here, oceanic plate. It will look like this. So this boundary, which is separating continent, this is known as suture zone. Now, since this continental plate is attached to this oceanic plate, so this continental plate will subduct. So what would happen? Continent in between oceanic plate, then we have continental plate. So again, mountains would be formed. This is trenches, right? But now, in case of volcanic activity, here magma is melting, it will rise. So now what would happen? Since thickness of continent, then thickness of oceanic plate. So magma has to travel so much of distance, so it is not able to reach the surface of the earth. So it solidifies before reaching the surface of the earth. It will form intrusive landforms. So ultimately what happens? Now earthquake is taking place, folded mountains are formed, occasionally wedges form, but there is no volcanic activity because magma is not able to reach the surface of the earth, because before reaching the surface of the earth, it cools down and solidifies because it has to travel huge distance. Oceanic plate first, it has to travel across the oceanic plate, then continental plate. So this is how continent convergence take place. So if we look at best example of these, in the first phase we find Eurasian plate, oceanic plate is Mediterranean plate, and African plate. So they are right now in the first phase. So Mediterranean plate, oceanic plate is getting destroyed slowly, and in the future, Eurasian and African plate will meet. So this has led to the formation of what Atlas Mountain in Africa, Alps mountain and Eurasian. And this is the reason why recently Turkey earthquake took place, because convergence between Eurasian and African plate. Then best example of phase two areas where phase two of continent convergence have been reached: Himalayas. How Himalayas have been formed? Eurasian plate and Indo-Australian plate. These have been formed, and we know in Himalayas we have high mountains, Mount Everest and all, but there is lack of volcanic activity. I would say there is no better term would be no volcanic eruption, but their presence of minor volcanism. How? Minor volcanism via geysers and hot springs. So there is no volcanic eruption, but minor volcanism is present. This is the better term. So they are found in Himalayas. I hope this is clear, right? So through this, what have been formed? Himalayas, Ural Mountains in the past, Alps in the Europe, Atlas formed due to African Eurasian plate. Same with the Alps. Appalachian Mountains have been formed in the past, right? Sometimes term is used Alpine Mountains. Alpine Mountains means young fold mountains, which have been formed presently. Which all are the Alpine Mountains: Atlas Mountains, Alps Mountains, Himalayas, and also in case of young fold mountains, we also include Rockies and Andes also. Just remember. All right. So what is the feature of young fold mountains? They have rugged relief, they have high height, and they have high conical peaks. So these are the basic features of these mountains. All right. Okay. So this is all about plate tectonics. And also last topic that we have is African Rift Valley. Let's have a look at it. Okay. In one part of Earth, this is Africa. Right? This is Africa. So what we have minor plates. Over here we have minor plate. Arabian plate. This is African plate, also known as Nubian plate. Right? Then we have this is East African plate का जो broken part है, known as Somali plate. Right? तो ये तो Indo-Australian plate होगी. Now see. And since this region, see, we have Arabian Peninsula, African Peninsula. So there's a gulf between them. This is known as Gulf of Aden. This sea region, ये क्या? Red Sea. Red Sea. Okay. All right. Okay, so if we look at this point, this junction point, see, this is Arabian Sea, Gulf of Aden, this is Red Sea, right? Okay, so what is happening? This earlier it was whole African plate. So, but now within the Africa itself, there is a crack has been developed. A plate is starting splitting. So it is broken into two parts: African plate and Somali plate. So we find trijunction like this. Already there was a line between Arabian plate and African Somali plate, but now Africa itself has started dividing, splitting. Right. So what is happening? Gaps is creating. Since gap is being created, it is leading to formation of what? Rift Valley. This Rift Valley is known as what? African Rift Valley. East Africa में Rift Valley create हो रही है, African Rift Valley, right? Or this junction where it is being created. This junction is known as Afar Trijunction, or we call it as Afar hotspot. Right? ये ध्यान रखना. So ये drift actually चल कहाँ से रहा है? ये देख लेते हैं. कहाँ से extend हो रहा है? ये यहाँ पे Dead Sea है, Red Sea, and it is moving in the Africa region. So it is moving along from Dead Sea. Then there is a Gulf of Aqaba over here. Gulf of Aqaba. Then it is moving along the Red Sea region. Then it moves towards Red Sea to Gulf of Aden. Then Afar Junction and towards the Eastern Africa. So this is how Rift Valley is extending. Right? And also before Dead Sea, we have Jordan River. Over here we have Jordan River, then Dead Sea, Gulf of Aqaba, Red Sea, and then African part. This is the extension of the these regions. Rift Valley, sorry. Clear? Just keep this thing in mind. Yes, nothing else from this point. Then because of this, we have one famous volcano, Mount Kilimanjaro. You need to remember this thing. That is it. Just basic African Rift Valley. There is a trijunction. 3 plates are present: Arabian plate, African, which is also known as Nubian plate, Somali plate, and extension of Rift Valleys from Dead Sea region, Dead Sea, Jordan River, Gulf of Aqaba, Red Sea, Afar Junction, and East African part. This is the extension of this Rift Valley. So in the right now, this rift has been created. So lakes are being formed. In future, this will widen. It will lead to formation of sea. Further, this will widen. This will lead to formation of ocean. So over here, lakes are formed. Over this region, it has widened. So it has formed sea. In future, it will split more, and it will lead to formation of oceans. So just this is all you need to know about this region. All right. East African Rift Valley. All right. I guess this is all you need to know about this. What else? Huh? This is you need to know about. And if you look into our books, I explained it. Rates of plate movements. Now plates are moving away from each other, right? So slowest movement that we are observing in the plates, we are observing in case of Arctic regions. It is moving at slowest rate, 2.5 centimeter per year. And fastest movement is observed in the East Pacific rise. In the South Pacific, west of Chile, it has fastest movement. So we have fastest movement of plates along this region, slowest movement along the Arctic region. Arctic region slowest, fastest is over Eastern Pacific rise. ये ध्यान रखना बस, states of plate one, because plates are moving differently at different phase. It is a unifying theory. We have already seen convection theory, high convection, how convection is created, radioactive decay, and residual heat. All right. Then there's a one topic in our book, NCERT itself, movement of Indian Ocean plate. So how Indian plate has moved. Earlier, Indian plate was peninsular plate. Peninsular plate was like this, but in future it started moving in the northward direction, and it changes position also. So earlier it was tilted, then it became straight, and ultimately it became straight and collided with the Eurasian plate, right? And it has been moving in the northward direction. So if you look at the present boundary of the this northern Indian plate, northern plate boundary we have. This is India. This is Australia. If you look at, it is colliding with the Eurasian plate. So how boundary is formed? Northern boundary is formed by the Himalayas, right? Eastern part, it extends from the Rakhine Yoma mountains of the Myanmar. One second, let me draw it. So how boundaries is being looks like this. This is boundary of red part is the boundary of the Indo-Australian plate. So if you look at the northern part, it is formed by Himalayas. Himalayas boundary. Eastern part is Myanmar. This is Rakhine Yoma mountains. Rakhine Yoma. Yoma means mountains only. Rakhine Yoma mountains of Myanmar. Then it moves towards the Java Trench. Because in Andaman Nicobar Islands, over here we have Java Trench. This is eastern boundary, right? Then further along the Australia, over here it has spreading side. Divergence is taking place, right? Then southern part, if you look at, it is in Indian plate and Turkey plate. Over here also it has divergent boundary. Divergent boundary over here, but over here it has convergent boundary because mountains are formed. Then western margin, over here it has Kirthar mountains. Kirthar mountains of Pakistan, right? Then it moves along the western coast of Iran, Makrana coast. Then it moves along the Red Sea Rift region. Because a minor Arabian plate, we say it is a part of Indo-Australian plate only. So it moves along the Red Sea Rift. Then over here, Lakshadweep, Chagos Island, Lakshadweep, Chagos Island, right? And moves southward. So this is south. Over here it has divergent boundary. So if we look at the boundaries, what we have, this is convergent boundaries, and these are divergent boundaries. But yes, convergent boundaries taking place here also, which leads to formation of New Zealand, and here New Guinea Islands and all. All right, this you need to know about. And earlier, Eurasian plate was separated by Indian plate by a sea known as Tethys Sea. So these are the boundary line. To remember this boundary line of India. All right. And as India moved, what happened? As India moved, this is equator. So before crossing equator, it encountered Reunion hotspot around 60 million years ago, right? So around 60 million years ago, it moved over the Reunion hotspot. It led to the formation of Deccan Traps. And as it moved forward across the equator, it entered over here. It collided with the Eurasian plate. It led to the formation of Himalayas. Yes. And today also, height of Himalayas is rising. What are the evidence? Earthquake is taking place. So these are the reasons. Movement of the Indian plate. I hope you will remember it. All right. Although UPSC has not asked question on this, but still we have to study this topic because it is part of a syllabus. All right. So this is all about plate tectonic theory. If anyone has any doubt, so I'll ask. Let's first complete this topic of rocks, then I'll ask doubts. All right. Okay. So next topic is minerals and rocks. This is also a favorite topic of UPSC for means only. In case of prelims, how it is asking question, it would be asking question on the minerals part. minerals part would be asked, not right? Because it has been asking question on the hematite before, iron ores, or location of some other minerals. Questions are being asked on this. So human geography aspect based questions. But before that, we need to understand the rocks part, because through erosion of rocks only minerals are formed. All right. So what you need see earlier we saw that earth crust. We saw earth crust has maximum element of one. We saw OSI call. This was the short form we learned. So oxygen, silicon, aluminium, iron, calcium, sodium, potassium. So these are the order. 98% of the total crust consists of 8 elements: oxygen, silicon, aluminium, iron, calcium, sodium, potassium, magnesium. Others are titanium, hydrogen, phosphorus, manganese, sulfur, carbon, nickel, and other elements. The UPSC may ask them in the ascending descending order. What their contribution to the composition of earth crust. So do remember these elements also. All right. So what are minerals? Minerals are nothing. It could be organic or inorganic substance, right? Which has definite atomic structure, chemical composition, physical properties, physical hardness and all. Chemical, it is made of some chemicals, reaction oxides could be something, and proper atomic structure. This is mineral, simple definition. UPSC won't ask you this, but yes, state exam may ask that, right? And mineral may compose of 2 or more elements, and it could be anything: sulfur, copper, silver, gold, anything, right? So basic source of all minerals क्या होएगा? Simply hot magma. Magma कैसे generate होता है? Rocks are getting melted. Rocks are made up of minerals. So those minerals come to the surface of the earth via magma, and when they reach the surface of the earth, they cool and solidify, and through these rocks only we obtain minerals, right? These are not important physical characteristics and all. Hardly UPSC will ask. If you really have time, you can read. Otherwise, no need. For state exam, you can read, of course, but not for UPSC. All right. For UPSC, we have 2 types of minerals: metallic and non-metallic. Metallic contains metal content. So we classify them into 3 types: precious metals, gold, silver, platinum; ferrous minerals, which contains iron; non-ferrous, which does not contain iron: copper, lead, zinc, tin, aluminum; non-metallic ones, which do not contain metal content: sulfur, phosphorus, nitrates. Best example, cement is a mixture of non-metallic minerals. All right. Our topic of discussion important is rocks. So what are rocks? This is a whole piece of rock. It may consist of one type of mineral or one or more type of minerals. This is simple. So it is an aggregate of one or more minerals, right? It may be hard, soft, different physical property would vary. Now UPSC has mentioned, so do remember these properties of various rocks. Granite rock is hard, soapstone is soft, gabbro rock is black in color, quartzite is milky white in color, right? And petrology is science of rocks. All right. So we classify rocks into 3 types: igneous, sedimentary, and metamorphic. So what are igneous rocks? Simply, these are primary rocks. Last year UPSC had asked directly question on this. What are primary rocks? Characteristics of the primary rocks and types of primary rocks. So how primary rocks are being formed? Nothing. Molten magma is formed. It rises. Now it may cool and solidify. Inside the earth, it will form intrusive rocks, or outside the earth, it will form extrusive rocks. But the rocks which are being formed, they are broadly grouped into one type: igneous rocks. So what are igneous rocks? It is nothing but molten magma which rises to the surface of the earth, or even inside the earth. It cools down and solidifies. So type of rocks which are formed are known as igneous rocks. Now size of the minerals inside the rocks may vary on the rate of cooling. If cooling is taking place at fast pace, what would happen? It will form small size grains. If cooling is taking at slow pace, it will form large size grains. Just keep this thing in mind. And these igneous rocks are also known as primary rocks. And type of primary rocks, you'll talk about intrusive and extrusive landforms only. Right? So if molten magma is cooled slowly, mineral grains may be large. Sudden cooling would form small and smooth grains. So examples of igneous rocks: granite, gabbro, pegmatite, basalt, volcanic breccia, tuff. And other properties which you need to know about volcanic is they have no fossils, because fossils are what? Dead remains of plants and animals. So whatever dead remains and plants and animals are there, all will get destroyed in the magma, so no fossils. Then they are non-stratified. That means we don't find rocks having different layers of different minerals, because one layer of lava is deposited, second layer of lava is deposited, third layer. So this whole rock is formed different layers, but we know all three lavas have same properties, so we are hardly able to discriminate or differentiate between the layers. So they are non-stratified, right? And they are crystallized. That means proper crystallization of grains take place. If it is fast cooling, slow crystals, sorry, low size crystals. If it is uh, slow cooling, large size crystals. All right. Then sedimentary rocks, how they are formed. These igneous rocks only, or also other type of rocks. We should be studying metamorphic rocks. Once they are eroded by erosion agents, like rock is there, even you humans, we break rocks. So pieces of rock is broken. That pieces of rock is carried away by the water, wind, or any other agent to some other place and deposited. So likewise, what would happen in a place? There will be presence of minerals, or you can say pieces of rocks of different sediments from different type of rocks. Now, due to some force, all these would be force compressed, and this will lead to formation of rock having different type of minerals, or minerals obtained from different rocks. So such rocks are known as sedimentary rocks. And this process of breaking up of rocks, transporting, and then compaction due to some force, this is known as lithification. Lithification, right? And in this, we may observe the number of layers also. Suppose one set of sediments are deposited, then another set of sediments, then third. So we may find different layers. So in this, we have layers also. Stratified is formed. And also there may be presence of fossils are also present, because fossils are also sediments. So presence of fossils, stratification, and lithification. These are the keywords you need to remember. Then examples, some rocks that force of compaction, maybe due to pressure you're putting up, mechanically formed sandstone, conglomerate, limestone, shale, loess. These are the examples. Or that compaction may be due to organic reaction, right? Through decomposition and all. So its example are geyserite, chalk, limestone, coal, and some chemically formed shirt, limestone, halite, potash. These are the examples that you need to remember. All right. Then we have next type of rocks is metamorphic rocks. See, you have igneous rock, sedimentary rocks. In this, there is no, suppose in these rocks, there is no change in the outer layer. There is only internal changes. Internal change may be due to internal change in form or composition. Form would be, suppose grains are present small size, its size becomes large, or large size are present small. So change in form or composition may be these grains only inside minerals that are present. Suppose iron was present, now it became iron oxide. So internal changes, that is change in form or composition. Change in form or composition within the rocks due to change in pressure, volume, or temperature. Due to these factors, if there is change in the rocks, so such type of rocks are known as metamorphic rocks. So new rocks that are created. So there is internal change, no external change. बाहर से आपको वैसा ही दिखेगा, right? So change of form. So form under the action of pressure, volume, temperature. So these rocks are known as metamorphic rocks. ये ध्यान रखना. So there is recrystallization and reorganization of materials within the original rocks. और कुछ चेंज नहीं है. अब अगर हम प्रेशर लगा, अब देखो इसको भी हम फर्दर क्लासिफाई करते हैं, राइट? वी क्लासिफाई इट एज डायनेमिक एंड थर्मल. तो अगर हम सिर्फ टेम्परेचर चेंज कर रहे हैं तो हम बोलते हैं थर्मल मेटामॉर्फिज्म. अगर हम प्रेशर लगा रहे हैं तो उसको बोलते हैं डायनेमिक मेटामॉर्फिज्म. ये ध्यान रखना, राइट? इफ वी आर sorry, original minerals within rocks are changed due to breaking and crushing without any appreciable chemical changes. They are known as dynamic. Thermal क्या हो गया? Due to temperature changes. अब उसको भी हम फर्दर क्लासिफाई करते हैं कॉन्टैक्ट, कि अगर रॉक कम्स इन कॉन्टैक्ट विद द मोल्टन मैग्मा, सो रॉक्स का टेम्परेचर इंक्रीज होगा, चेंजेस वुड अकर. सेकंड कुड बी हम एक बड़े रीजन पे फोर्स लगा रहे हैं, तो आप किसी रीजन पे फोर्स लगा रहे हो, व्हाट वुड हैपन, हीट वुड बी प्रोड्यूस, दैट हीट would be used to heat up the molten heat up the rocks, and changes would take place in the rocks. That is regional metamorphism. So contact and regional metamorphism, right? So regional metamorphism, basically it usually takes place during tectonic activities. So huge piece of rock is forced from both the ends, folding of rocks will take place, and heat would be produced, and rocks will transform into metamorphic. So if you remember, I have written in the above case metamorphic rocks. So in case of continent convergence, compression forces taking place from both the ends, heat would be produced, so rocks are changed into metamorphic rocks. Keep this thing in mind. So these are the metamorphic rocks. Now in case of metamorphic rocks, what we may find, that minerals might get arranged in the layers form. So this is known as lineation or foliation. Lineation and foliation. Or sometimes rocks may get arranged into bands of thin layer, thick layer, thin layer. This is known as banding, right? So what are keywords you need to remember? Metamorphism, regional metamorphism, contact metamorphism, foliation, lineation, banding. And examples: gneissoid, granite, syenite, slate, schist, marble, quartzite. So these are the examples. याद करने हैं. There's no solution for it. All right. Then we have rock cycle. Rock cycle is simple. Igneous rocks, these are primary rocks formed due to magma. Magma rise हो रहा है, solidify हो रहा है, right? So up, if these rocks are subjected to weathering and erosion, it will lead to formation of sediments, and lithification process of sediments, it will lead to formation of sedimentary rocks. Same would be case of metamorphic rocks. It goes under same process, sediments are created, lithification process, sedimentary rocks, right? Sedimentary rocks, if it undergoes metamorphism, it creates metamorphic rocks. Same igneous rocks goes under metamorphism, creates metamorphic rocks. Again, both metamorphic and sedimentary rocks, if they are pushed down into interior of the earth, it will lead to formation of magma, melting of rocks, magma would be formed, solidification of magma, it would form igneous rocks. So this is rock cycle. So from one type of rock, we can get other two types of rocks. All right. So you need to remember a few examples. Igneous rocks, sedimentary rocks, granite. If it comes under influence of pressure, it forms metamorphic rocks known as gneiss. Granite se gneiss under pressure. Clay shale se under pressure creates schist. Sandstone under heat, that means thermal metamorphism, creates quartzite. Clay shale se under temperature creates slate. Further increase in temperature creates phyllite. Remember, clay shale on pressure creates schist. Clay shale on heat creates slate, phyllite. Coal on heat produces anthracite, then graphite. Limestone on heat produces marble. You need to remember these because it can be asked in the prelims. All right. Then some important minerals, because UPSC had been asking question on these, and we will be exploring for sure minerals topic in detail, like where minerals are found in India and their properties also. But for the basic part, let's have a look at feldspar, right? It has silicon, oxygen, sodium, potassium, calcium, aluminum. It is used for ceramics and glass making. Quartz, famous one. It has silicon and oxygen, right? It is used to manufacture of radio and radar. Bauxite, it has presence of minerals known as aluminum. Bauxite are associated with aluminum. UPSC had asked question on this previous year. Right question. Ki which minerals are obtained from the bauxite ores? So bauxite is ore of aluminum. Cinnabar, it is what mercury sulfide, and mercury is derived from it. So from cinnabar, mercury is derived. I hope you remember uh, in the case of Harappan also, we found use of cosmetics. So how cosmetics were produced? It was produced using cinnabars. Even in today's time, cosmetics are used using cinnabar, and they are quite harmful for health. That's why we are now moving towards using algae to produce cosmetics. What cinnabar has? Mercury sulfide. Remember, dolomite. Remember karst topography, calcium and magnesium carbonate. So it is used in cement and iron and steel industries. Gypsum, calcium sulfate, used in cement, fertilizer, and chemical industries. Hematite, it is red ore of iron. Magnetite, black ore of iron. Hematite, magnetite. Amphibole, it consists of aluminium, calcium, silica, iron, magnesium. Just you need to remember it is used in asbestos industry. Because of presence in asbesto industries, it is creating a harmful effect on the labor. Mica, recently it was in news. So it consists of potassium, aluminum, magnesium, iron, silica, right? It is used in electrical instruments. Then olivine, they are found in the olivine are found in the mantle part, right? So it consists of magnesia, iron, silica. You can see in mantle part we have sema, silica, magnesium, right? So they are found in mantle part. Olivine, pyroxene, it consists of calcium, aluminum, magnesium, iron, silica. I hope all these elements are same in all. Calcium, aluminum, magnesium, iron, silica, sema, Cl, right? So do keep this in mind. Rest of the minerals will explore. So you have to remember these because UPSC is asking question on these regions, areas, right? All right. So let's do this some map work because we have not done any map work since a long time. So let's complete some map work and then we'll wrap up our class. All right. So we have done the India location part, right? We have done all the locations of India. क्या कहते हैं places, states, boundary shared with different nations, right? Then northernmost point, southernmost point. Yes, एक correction कर लेना. I talked to you about Pygmalion Point. Pygmalion Point is not Indira Point, which is northern point. It is rather, sorry, not Indira Col, which is northernmost point. Rather, it is Indira Point, which is southernmost point in the Andaman Nicobar. That is known as Pygmalion Point. I guess in the previous class I said Indira Col is known as Pygmalion Point. Let's ये change कर लेना, right? All right. Now Indian geography, physiography. Basically, we know different physiography of India. So what we have, Himalayas, northern plains, which consist of Indus, Ganga, and Brahmaputra plains. Then we have islands, right? Then we have plateau, right? So these are the regions that we have to study: Himalayas, northern plains, plateau, basically peninsular plateau, then coastal region. So these are the physiography of India, right? How they are formed due to interplay of exogenetic and endogenetic forces. We'll explore this in the next class, endogenetic and exogenetic forces. All right. So this is about physiography. Now we'll be exploring each and every region. First, we'll start with the Himalayas. Then we'll talk about northern plains, peninsular plateau, islands, coastal regions. Okay. First of all, this basic, you need to just have a basic idea. UPSC will never ask question on this, but just basic. See, we find older rocks. Where older rocks are found in peninsular part. So these are the regions where older rocks are formed. This is Aravalli region, right? This is Chhattisgarh, Odisha region, and then southern region. Here, older rocks are formed. They are stable, so there are no activities observed, well, earthquake activities, right? Then Himalayas, they have been recently formed in the tertiary period, so that's why we call Himalayas as young mountains because they have been recently formed. Then Indo-Gangetic plain, over here we have sedimentary rocks, so they are formed by sedimentary. In case of Himalayas, we have metamorphic and igneous rocks. Metamorphic and igneous, covered by the layer of sedimentary. In case of Indo-Gangetic plain, in plain area, if you are living in Delhi, UP and all, you'll see it is completely made up of sedimentary rocks. Right? This region, stable rock ones, they are completely made up of metamorphic rocks. Right? Then this pink shaded part, these are Gondwana regions. They are famous for minerals, coal, iron ore, and all. So along this pink regions, you will find all the minerals. So if you'll have basic idea of where all Gondwana and Vindhyan regions are formed, so it would be easier for you to mark the minerals on the map. And we'll be exploring minerals also, right? Then we have Deccan Trap, right? So here we have basalt rocks, black soil. UPSC had asked question in the prelims earlier. Deccan traps are made up of what type of rocks? Basalt, granitic rocks, and all that. So it is made up of basalt rocks. Actually, question was black soil found in the Deccan region made up of what? So it is made up from basalt rocks. Right? This is the basic you need to remember, and also basalt rocks are present in Gujarat region also. This is you need to remember. Geological basically means type of rocks found in India. So just broader classification we have seen. All right. Okay. Now let's start with the Himalaya mountain ranges that we need to remember. डरना नहीं है पर याद करना है हमें. Now see, northernmost India we have one range, Karakoram range. Karakoram range, right? We actually classify Trans-Himalaya, Himalayas into two, Trans-Himalaya and normal Himalayas. So Trans-Himalaya consists of Karakoram range. Then we have Ladakh range, Zaskar range. So these three are Karakoram Himalayas. Karakoram, Ladakh, Zaskar. So these three ranges are part of Trans-Himalaya. So they were formed by, now see how Himalayas were formed. Continent convergence. So first phase was ocean continent convergence. So then only there was continent convergence. So in the first phase, ocean continent convergence, the Himalayas that were formed, those were Trans Himalayas. And over there we have volcanic mountains, or you can say volcanic rocks are also formed. So Trans Himalayas are what all? Karakoram range, Ladakh range, Zaskar range. Only then whole oceanic plate went, and there was formation of Suchar zone, Indus Sangpo zone, and then there was convergence of continent convergence, and rest of the Himalayas were formed: Greater Himalaya, Middle Himalaya, Outer Himalaya. Right? Keep this thing in mind. So Karakoram range, Ladakh range, Zaskar range. Right? This Ladakh range only when it moves to Tibet region, it is known as Kailash range. Zaskar, Ladakh, and Karakoram, Ladakh, Zaskar. All right. Then in the north of the Karakoram we find Kunlun Shah. Kunlun Shah mountains. On the west it has Hindu Kush. And in the south it has Suleiman. Then it has Kirthar. I hope you remember Kirthar forming the western boundary of the Australian plate. So Suleiman Mountains, Hindu Kush, Kirthar, Kunlun Shah. And they all meet at one point. It is type of a knot. Kunlun Shah, Karakoram range. Over here Hindu Kush, Suleiman. So it is rising from one region which is known as Pamir Plateau. So do mark this region. This is what Pamir Plateau, or Pamir Knot also we say. 5 places we have talked about: Karakoram, Ladakh, Zaskar, and Pamir. Pamir से क्या क्या राइज हो रहा है? कुल्लू शाह, हिंदू कुश, सुलेमान, किरथार. I hope this you will remember. All right. Too much of information. Here, NCRT. Karakoram range, it has peak, K2 peak, which is also known as Godwin Austen peak. Godwin Austen peak. Then have Pamir Knot, Kulun Mountains, Hindu Kush, Karakoram. Pamir Knot, right? And Ladakh, which is also known as Kailash range. Zaskar. Zaskar has Nanga Parbat. अब नंगा पर्वत क्या है? See, Indus River is coming and around Nanga Parbat it takes 90-degree turn. It forms gorge and it takes 19-degree turn. So it is Nanga Parbat, right? Nanga Parbat. And likewise, Brahmaputra, it takes 90-degree turn in the eastern Himalayas at Namcha Parva. We also call them as syntaxial bend. This is also UPSC had asked in the previous sir. The syntaxial bend is found by Himalayas in two regions, where Nanga Parbat and Namcha Parva. Nanga Parbat in western Himalayas, Namcha Parva eastern Himalayas. So so Himalaya looks like this. Long days. It looks like this. So 90-degree turns over where there is sudden change in the direction of the Himalayas. These are known as syntaxial bend. And where all Nanga Parbat, here Indus River flows, here Namcha Parva, from here Brahmaputra river flows. Alright. Then we have south of Zaskar ranges, we have Great Himalayas. So Great Himalayas has various passes. One is famous Baralachala, then Shipkila. La means pass. Alright. So Trans Himalayas, Karakoram, Ladakh, Zaskar. Now we'll talk about normal Himalayas. First is Great Himalayas. So here, this is Western Himalaya. We move towards Eastern Himalayas. Namcha Barwa, Great Himalayas is continuing, right? I hope you will remember this. Karakoram, Ladakh, Zaskar, Kailash Range, Great Himalaya, Nanga Parbat, Pamir Knot, Kullu Mountains, Hindu Kush. K2 peak is also known as Quadman Austin Peak, which is present in Karakoram Range. Greater Himalayas is going Sangpo River, that is Brahmaputra River, because Brahmaputra River is known as Sangpo in this region. What do you call Tibetan region? And it is taking 90-degree turn. See, this river is coming, taking 90-degree turn as syntaxial bend, which is at Namcha Barwa. Okay. All right, keep these basics in mind. Then we have now Zaskar, right? Then we have Pir Panjal range. Between Zaskar and Pir Panjal, we have a valley which is known as Kashmir Valley. Right? Zaskar, Pir Panjal range. Between Zaskar and Pir Panjal, we have a valley which is known as Kashmir Valley. In continuity of Pir Panjal, we have in Himachal the same mountains, middle Himalayas only, Dhaulathar. In continuity, we have Nag Tibba and Mussoorie range. And this is a region where you all want to go and you all will definitely go, Mussoorie range. In continuity, again we have in Nepal of middle Himalayas, Mahabharat Lake. Then it disappears. So middle Himalayas consists of Pir Panjal. In Himalayas, it is known as Dhaulathar, Nag Tibba, Mussoorie range, Mahabharat Lake, right? All right. Then we have south of middle Himalayas, we have outer Himalayas, Shivalik. Shivalik is running like this. So Shivalik is running along the south of the middle Himalayas. All right. So it runs continuously till this region, Nepal region, but then it gets broken up. It brokens up into small parts. So in Assam, it is known as Mikir Hills. Sorry, in Arunachal, Dafla Hills, Miri Hills, Abor Hills, Mishmi Hills. Dafla, Miri, Abor, Mishmi. So it looks like this. Dafla Hills, over here Miri, Abor, Mishmi. So these are the hills. And in case of Dafla Hills, we have a famous law, Bomdi law. Alright. So these are the, just remember these right now. We'll continue with these because it's too much of information to remember. But yes, if we'll keep looking at these places daily, 10 places, if we'll look at, so whole map would get revised. Alright. And I'll try to make this diagram more clear tomorrow because this is a bit confusing map, right? Not with clarity. All right. So this is all about today. So we have covered good section of topics today, right? So any of you has any doubt, please to ask.
As you said in the, excuse me, sir. Hello.
Sorry.
Can you hear me?
Yes, I can hear you.
As you said in the Himalaya region, there is not volcanic eruption, but there is a presence of volcanism in the form of like geyser, hot water kind of things.
Yes.
Is there a chances of in the future occurring of there like volcanism there?
No, volcanic eruption would not occur. Why? Because see, lava is being generated because Indo-Australian plate is getting subducted under Eurasian plate. But that lava is not able to reach the surface. Why? Because of huge thickness. See, it has to travel across the oceanic plate, which is between Eurasian and Indo-Australian plate. And then again, it has to travel across the Eurasian plate, that is continental plate. And it is also has the huge thickness of around 30 to 70 kilometers. So what happens? Lava is being generated, but it is not able to reach the surface of the earth. So because of that, before reaching the surface of the earth, it cools down and solidifies. And there is no volcanic eruptions, right?
Okay, thank you.
Yeah. So in the future also, there won't be any volcanic eruption.
Yes, sir. Because of this reason, we found volcano in Black Sea and Caspian Sea.
See, in those regions, in case of Mediterranean Sea, we find the volcanic activity, because over there it is in the first phase of the continent convergence. What we are observing, this thing, Eurasian plate and African plate, they are converging. So there is continent convergence, but they are right now in the first phase. That means oceanic and continent convergence. So right now, Mediterranean plate is getting subducted under Eurasian plate. So magma is getting created. So magma has to rise just above the, it just has to rise across the one plate only, continental plate. But in case of Himalayas, we're finding two plates through which lava has to rise. So that's why in the Mediterranean regions or Alps mountains, we find volcanic eruption, but not in case of Himalayas.
Yes, sir. But I was asking that उसमें Black Sea and Caspian Sea में भी दिखता है ना volcano कुछ?
No. There is no volcanic eruption in those regions.
No, sir. I think I have previous year question. उसमें था कि Baltic Sea के अंदर volcanic eruption नहीं होता और जो तीन दिए थे ना Baltic, Black Sea, Caspian Sea, and I think एक और sea था.
See, there could be minor eruptions, but not that major eruptions over there. So usually we consider them as the no eruptions, but yes, see, across the earth, there can be some kind of horsepower volcanism present over there. So it might be possible, but we don't see it. And do share me that question in the previous question, but I don't think so. There's volcanic eruption in those regions. There could be minor eruptions, but not major one.
Okay, sir. And sir, some people say that the Jaskar range is a part of Greater Himalaya.
No. It is part of Trans Himalayas. Jaskar ranges, Trans Himalaya. It was formed due to interaction between Tethys plate, because between Eurasian and Indo-Australian plate there was Tethys plate, Tethys Sea. So Tethys Sea plate and Eurasian plate, it was formed through that mechanism, not through Indo-Australian and Eurasian plate convergence. So it is not part of Greater Himalayas.
Okay, sir.
Recent Turkey earthquake is a continent conversion or either ocean or continent conversion?
See, in case of Turkey earthquake, we will say simply it is continent convergence. That means convergence between Eurasian and African plate. But yes, within continent convergence, it is in the first phase. That means Mediterranean plate, Mediterranean minor plate, and Eurasian plate. But best answer would be continent convergence only.
But you said that there is a transaction of the Somalia and African and
they are in the first phase of oceanic and continent convergence. But if you look at the broader picture, in the future, actually, which plates are moving? It's the Eurasian plate and African plates which are moving, and minor plate is getting pushed to subduct below the Eurasian plate.
Sir, can you explain about the recent Bhuj earthquake and this one? Is there any connection link between this one?
So see,
Turkey?
in case of Bhuj earthquake, is due to faulting. What happened in the Indo-Australian plate? There was a minor crack which developed. So because of that, earthquake happened. It was not due to convergence or something like that. It is like simply a piece of paper and a crack develops in the. You pull the piece of paper from both the ends. So what happens? There's a minor cracks developed within the paper. It's like that. Within the Indo-Australian plate, a crack was developed. We call it as Allah Bund fault. I talked about yesterday also, Allah Bund, ALLAHBUND, Allah Bund fault. So because of that, Bhuj earthquake took place. So it is due to faulting, not because of not along the margins of the plate. So
Okay,
it
it's
occurred
not in
within
the-
the plate itself.
Okay, it's not in the margin of plate.
You can say it's a minor plate between them, but simply you just say it is because of faulting. Because if you'll go into deep in depth, it would be an optional level concept. So you just need to remember basic thing. It is due to faulting. Allah Bund fault was responsible. That is it in Gujarat.
Is there any chances of occurring there in future also?
Yes,
think
anything can happen. It is possible
Okay.
because we are not
I
able
think-
to predict earthquakes.
I think it is
and
zone 5.
we have not
zone
gone
5.
inside the interior of the earth.
Bhuj is in the zone 5, I think, sir.
Yes, it comes in the zone 5. We will cover these zone areas also when we'll cover Indian part of earthquake. But yes, because now recently earthquake has occurred in this region, so it comes under zone 5.
Okay, thank you, sir.
There is a one question that minor plates goes under subduction only. No, it is not necessary. Minor plates may go divergent also. Like we have seen in the case of East African Rift. A plate was there, African plate, it split it into two parts, Nubian plate and Somalian plate. Now what is happening? Somalian plate is minor plate and there is showing sign of divergence. Likewise, Arabian plate and African plate. Arabian plate is also minor plate. So we are observing divergence between African and Arabian plate. So anything can happen. Divergence is also possible. Convergence is also possible. Now see, these things are controlled by nature, not by humans. So whatever happens, it happens. So we just have, in case of geography, see, there's no logic, there's no science. We just observe and say, yes, it is happening. And then we try to explain why it is happening. But still, we are not able to completely explain each and every phenomenon on the earth. Right?
But sir, general theory about the subduction is that minor plate is inside the larger plate.
No, it's not like that. It is not necessary.
Okay.
Anything can happen. Divergence is also possible. See, simply what is happening, two plates are present. Two plates may move away from each other also. So minor plates may also move away from each other. But yes, what we have seen in our examples right now, like across the world map, 7 major plates and then minor plates. So we have seen, with respect to minor plates, we have seen the convergence only. But divergence is also possible, as I have shown you the example, East African Rift. Okay, any other doubt?
No, sir.
Okay, then let's wrap up.
Yeah, sir. In Himalaya region, there are indigenous rocks, but the volcano is not generating because that lava is not reaching toward the surface. Yeah, is it right?
Yes.
Yeah.
It's like igneous rocks are forming the base of the mountains, and at the top of the igneous rocks, we find the sedimentary rocks. So basically, if you go to Himalayan region, you'll find the sedimentary rocks. You'll be walking on the sedimentary rocks, but inside the mountains, in the middle of the mountains, you'll find the igneous rocks, and also below that igneous rocks, you'll find the metamorphic rocks because of heat generated, those igneous rocks have transformed into metamorphic rocks.
Okay, sir. Thanks.
Yes. Okay. I hope you all don't have any other doubt. So let's wrap up our session, right? So if you have any other doubts, so you can just message me personally or post it in the YouTube video also, right? Okay, then thank you so much. Have a nice day ahead. We'll continue with our session tomorrow, right?
Thank you, sir. Thank you.
Thank you, sir.
Thank you.